All right, here we go. So this is the second video now. So here's the deal. You got another theorem up here. It's again a little on the wordy side, but I want you to understand that what I did is I took three different theorems and put them into one, and you've seen me do this before. So the measure of an angle formed by either option one, two secants. Remember, secant was a line that goes through the circle in two spots, right? Now like a tangent that kisses. All right. So the measure of an angle formed by either two secants or a secant and a tangent, or two tangents intersecting outside the circle now, so now it's the angle formed outside the circle, is equal to 1/2 the difference of the intercepted arcs. 1/2 the difference of the intercepted arcs. So that's the key phrase on this one. All right, so each one of these, P, 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 right, they're all going to be equal to 1/2 the difference of the intercepted arcs. So before we even get into it too much, let's focus on making sure we know what the intercepted arcs are. Again, the portion of the circle that it's eating. So if I look at angle P here, it's eating that piece and it's eating that piece. All right, here on this P, it's eating that piece is inside and then this piece. And these are like kind of like adjacent arcs right there, right? And then here, you got this piece. Okay, then you got, I guess if there's got to be two pieces, you got the other piece here. Well, there's something unique about those two arcs, but we'll get to that. So, back to the first one. So what I want you to understand is that when you're looking at angle P right now, it's going to equal to 1/2 the difference of the intercepted arcs. So 1/2, so the measure of angle P would equal 1/2 of the difference of the two arcs. So your two arcs here are AD and BC. Now just go back to like, I don't know, kindergarten subtraction. All right, obviously it's got to be the larger arc subtracting the smaller arc. So you're going to say AD minus BC. Okay, so in this case, if I throw some values in there, let's say I make this arc here 40 and I made this arc here 90, the expectation is that you can solve for angle X or angle P pretty easily here. All right, so you'd be looking at 1/2 of, obviously, bigger minus smaller. All right, 90 minus 40 is 50. Half of 50 is 25 degrees. Okay, subtract them, cut it in half. Done. All right, the hardest part of this is remembering the relationship. Now, fortunately, the relationship is exactly the same here for all three of these, all right, with one or two little tweaks. All right, so again, if I'm looking here, the measure of angle P would equal 1/2 of the difference of the two arcs. So you got the bigger arc, AC, minus the smaller arc, BC. Whatever the letters are in your picture, obviously you adjust it. So here's your relationship for this picture. Now, let's say I told you, okay, BC was 90. Oh, well, great. Okay, so if that's the case, all you need to know is this arc. Now, maybe I just decide I'm gonna be annoying. So I'm like, yeah, I don't give you that one. I give you that one. All right. So before you freak out, you sitting there and you're like, well, hold on a second. I know all the way around the circle is 360, and this circle in this picture seems to be broken into 1, 2, 3 arcs. So if you know two of them, well, 90 and 110 adds up to 200. So you could always subtract and figure out 360 minus 200 and get the 160 degrees that's there. All right, now maybe it's given to you, maybe it's something you got to figure out, but either way, we're talking about, kind of light work in that. So anyhow, so you're here, measure of angle P then would equal 1/2 of, I'm not going to use the 110 because it's not one of the intercepted arcs, I just used it to figure out the missing intercepted arc. Again, larger arc minus smaller arc. All right, so 160 minus 90 is 70. Half of 70 is 35. All right, so the measure of angle P for this picture would be 35. All right, now, so that's a tangent and a secant. Tangent, secant. All right, now the last scenario is tangent, tangent. All right, now, old school approach, especially with what I'll do in the next video, this was like the hardest one. But new school approach, it's actually really easy, so stay with me. All right. What was special about this one is on this one, I'm not going to give you both the arcs. I'm only going to give you one. All right. If I tell you this minor arc, the smaller arc is 150 degrees, that's all you need, because in this case, the green arc and the blue arc obviously make up the whole circle. So if you know this is 150, you can figure out the major arc here at arc ACB by just doing the simple subtraction. All right, so now you know this arc here is 210 degrees. Okay, they add up to 360, that makes sense. So you're looking at, again, to stick to the theoretical first, the measure of angle P would equal 1/2 the difference, fine. Arc ACB, remember I need a third letter when I'm going the long way in an arc greater than 180, all right, minus the minor arc of AB. All right, okay, same thing, equals 1/2 of 210 minus 150. All right, 210 minus 150 is 60. Half of that is 30, so the measure of angle P equals 30. But what I'd like you to recognize here, and if we were in class, we'd spend a lot more time and go into more detail on this, of course, and I'd have it as like a discovery practice, but look at this. You got a relationship here with what worked out to be 30. All right, and we do a couple scenarios, and what you'd see is that these two numbers always add up to the same thing. All right, and obviously you're looking right now, so you can see that 150 and 30 adds up to 180. All right, so they're kind of like supplements, and I would make this big, like, can I get my double? I would do like the air quote supplements, because they're really not supplements. They're not, supplements are two angles whose sum is 110, and this is an arc, and this one's an angle, so they're not technically supplements, but they kind of are. So, and this is only, all right, here, let's underline that like 37 times. 37. All right, so only with tangent, tangent. The angle and minor arc, all right, so the smaller inside arc, are supplements. Only, all right, with tangent, tangent. All right, so that's a helpful thing to kind of, breeze through the tangent, tangent thing. All right, so only with tangent, tangent, minor arc, angle, add up to 180. Okay, so that's the first approach to these problems for these three scenarios. All right, we'll do a second one in the second video, and we'll take it from there. All right, hoping this makes sense. You just got to focus on where the intercepted arcs are, and of course, remember that you're dealing with 1/2 the difference of the intercepted arcs. That's huge.